Welcome to LabMinutes.com in our lab video series on Cisco DNAC 2.1. This is Matha, your instructor for this video series. For a complete list of DNAC and SDA videos, you can visit our website under the Routing Switching section. There you can also sign up for our newsletters to receive the latest video updates. At this point of our lab video series, we have the underlay devices added to DNAC inventory and had all of the required design parameters in place, so we are ready to create our SDA fabric. We talked a lot about SDA fabric in the introduction and fundamental videos, and now we are about to see all of those in action. If you're not familiar with the concept of SDA fabric, you might want to check out those videos first so you can follow along. Otherwise, let's get to our lab. In our lab setup on the server VLAN 32, we have the DNA Center server at the IP of 172.16.32.111, a Windows 2019 domain controller DNS server at the IP of .40, and a Cisco ICE at the IP of .102. And all these servers are sitting on our core switch, switch 1, that provide access to the internet. We have created an underlay, that's made up of a router BC1 that we're going to be using as a border control. Then we have two edge switches, E1 and E2. At the middle, I use the switch 1 to provide layer 2 connectivity, so that way also we can perform some packet capture if needed. Connecting our fabric to our core switch is the Cisco FTD firewall, which has been configured just to pass everything through, back and forth, so no policy enforcement at this point. Connected to our edge switches are a number of endpoints with various types, ranging from Cisco IP phone, a printer. We also have a bunch of access points spread throughout our edge ports. And then we have to test Windows 10 machine as well, one on E1, Win 10-test1. That's currently configured with the static IP of 172.16.65.10. And then the second Windows 10 is connected to E2, so that way we can test the connectivity between the edge switches through the fabric. That guy is a Win 10-test3 and has the IP of 65.20. The printer over here also have a static IP of 65.11. These are some of the VNs that we will be creating in this lab, infra VN, which is there by default, the admin, the prod, and the guest. So goal here is to build the SDA fabric on top of the underlay network that we already have and provide connectivities within the fabric to our endpoints while creating all these VNs. Before we begin, let's go over some of the terminologies. The first terminology is fabric site. And fabric site is an area that is running SDA fabric with its own unique set of fabric components. This includes things like control plane nodes, border, and the edge. And if you need wireless, also wireless LAN controller. A fabric site can be single, multiple, or a subset of location. A rule of thumb I would say is that all devices should be in a close proximity and connect over high-speed network. If locations are separated by a WAN, they are typically considered a different fabric sites. The next terminology is transit network. Transit network is a network that connects or interconnects either between fabric sites or fabric sites to external IP network. And there are different types of transit network, which we'll go over in a little bit. And then the last one is fabric domain. And the fabric domain is a fabric boundary that is made up of one or more fabric sites that are connected together via a transit network. They are under the same network design and policies. When designing a fabric, geographical distance is usually what determines the scope of a fabric site, and then the type of the WAN that you have would determine the type of the transit network that you need. The next design criteria I would say would be a scalability number. A fabric site can only be so big, and if you have a campus that exceeds what a fabric site can support or scale up to, you may need to break up your campus to multiple fabric sites. Either way, make sure to check the scalability number on the latest Cisco documentation.